All right, guys. So in this video, we're going to go through how to solve the part 2 and 3, the open-ended questions in the final exam review. So first off, part 1, again, that was the multiple choice. You have that video previously. Part 2 and 3. Part 2 is your short answer. Each of these questions will be a total of 30 points. And then the part 3, the longer ones, is a total of 40 points on the day of the final. So question 1 here says, find the value of x of the triangle if the area is 42. Okay, so first off, you have to remember what the area formula for a triangle is, due to the fact that they're telling you you're using the area of a triangle. So area of a triangle is 1/2 base times height. Now on the test, it might be a triangle, it might be a square, it might be a rectangle, it might be a circle. Okay, so you want to know your area formulas. So area of a triangle, 1/2 base times height. So the area is 42. So that's going to go where A was. Then I have 1/2. Here's my base, and here's my height. So base is 2x plus 8, and the height is x plus 3. Now, you have to solve this for x. You can do this a bunch of different ways. You can choose to multiply out your two binomials first, then distribute the half. You can move the half first, whatever it is you want to do. I'm going to choose to distribute that half just because these are even numbers. It's going to distribute nicely. So you get 42. A half times 2 is 1x. A half times 8 is 4. And then we got x plus 3. You only distribute to the one it's touching. So that's why it doesn't go to the x plus 3. Then I can multiply this out, FOIL it. You get x squared plus 4x plus 3x plus 12, and combine it to get your 7x. From here, move that 42 over, subtract it, and we're at this point, okay? I want to factor this so I can solve it. So factors of negative 30 that add up to a positive 7 would be a positive 10 and a negative 3. So that means I have an x plus 10 and an x minus 3. Set each of those equal to 0. I'm going to do that over here. And you would solve it. So we get x equals negative 10 and x equals 3. Now, negative 10 does not make sense in this problem because if I plug a negative 10 back in to my height, negative 10 plus 3 is a negative 7. You can't have a negative height. So this is what we call extraneous. It's an answer to the factor, but it's not an answer to the original problem. And x equals 3 is my solution. So 3 is the value of x. That gives that triangle the area of 42. Okay, question 2, dividing. When we're dividing, you're going to take what you're dividing by. X squared minus x plus 1. That's going on the outside. That's your divisor. Then on the inside is the dividend. Now, anything that is missing, like I go from an x to the 4th, I'm missing an x cubed, I got to put a 0, I got to put a placeholder. Okay, and then everything else I have. Okay, as we go through this, you look at your first terms. So what do I have to multiply an x squared by to make it an x to the 4th? Well, I would multiply by an x squared. X squared, you distribute. X squared times x squared is an x to the 4th. X squared times a negative x is a negative x cubed. X squared times 1 is a positive x squared. Okay. We're going to take this, subtract everything down. Okay, these will cancel. 0 minus a negative is a positive x squared. 2 minus 1x squared is x squared. And then you drop down the next term and you repeat the process. What do I have to multiply an x squared by to turn it into an x cubed? Well, that would be an x. And again, same thing, I'm going to distribute. X times x squared is x cubed. X times a negative x is a negative x squared. X times 1 is a positive x. And again, notice as I'm doing this, everything's lining up perfectly. If your values don't line up, then you're missing something. An x cubed should always line up over an x cubed. Again, those will cancel. Subtract down. So x squared minus a negative x squared is a positive 2x squared. Negative x minus x is a negative 2x. And then drop down your next term. Okay. 2x squared. What do I have to multiply an x squared by to make it a 2x squared? Well, that's easy enough. It's just a 2. It's positive 2. Multiply. So 2 times x squared is 2x squared. 2 times a negative x is a negative 2x. 2 times 1 is a positive 2. Subtract down. Okay, cancels. Negative 2x minus a negative 2x. Well, that also cancels. That's a 0x. 5 minus 2 is a 3. And this is my remainder. Technically 0x plus 3, but it's really just a 3. And then you put together your full answer is your quotient up top, x squared plus x plus 2 plus the remainder over what you divided by. So over x squared minus x plus 1. And this is your final answer for your division. Okay. Number 3. It says in the table shown, I represents the imaginary unit. Remember, I is the square root of negative 1. Okay. Select all cells in the table for which the product of the row and the column is a real number. Basically means contains no I. That's what we're looking for. So if I go through and do this multiplication, negative 3 times I is a negative 3I. Negative 3 times negative 4 is a positive 12. So that's definitely a real number. So I got this one. That first one still had I in it. I times a negative 2I is negative 2I squared. Now, I squared is the same as square root of negative 1 squared, which is just a negative 1. So technically, excuse me, this answer here, this negative 2I squared that I have, is the same as doing negative 2 times a negative 1. So anytime I get an I squared, I can replace it with that, which is a positive 2. So this is actually a answer. Negative 4 times negative 2I is a positive 8I. Still have an I, so it's not that one. 5 times I is 5I. That's not it. Negative 4 times 5 is a negative 20. That is one. I times I squared. Now remember, I just said I squared is the same as negative 1. So I could treat this as doing everything times negative 1. So I times a negative 1 is a negative 1I. That's not a real number. And negative 4 times I squared, or negative 4 times negative I, is a positive 4. That's a real number. Okay, so basically, this is going to be important to know that I is the square root of negative 1, and I squared is the same as negative 1. And we can replace that value. Okay, number 4, 6 friends go to a movie theater. In how many different ways can they sit together in a row of 6 empty seats? Okay, so we have to decide, is this a permutation or a combination? Does the order matter? And in fact, it does matter, because no matter where I sit in a seat, I cannot sit in another seat. I'm only one person. So it matters the order I sit in, right? I can't be sitting in 2 different seats. That would mean order didn't matter. So it does matter here. We have 6 seats. We're picking with 6 people. That is 720 ways. You just put that in that calculator that I showed you when we did combinations and permutations. Now, if you weren't sure what you were doing, you weren't sure if it was P or C, I will tell you every combination, if it has the same amount, the 6 seats and the 6 people, 6C6 would come out to just be 1. And that's not just one way. So you could obviously look at the values they give you on the calculator. If you see where it's 1, you're not going to use that one. All right, and our last problem says factor completely. So first thing you want to do is look for a GCF. 3x to the 8th plus 3x to the 5th minus 60x squared. Well, they all are divisible by 3. They all have an x, and x squared is the smallest one. So I'm going to take that out. 3 divided by 3 is 1. X to the 8th, take away 2 of them, leaves me with x to the 6th. 3 divided by 3 is another one. X to the 5th, take 2 away is x cubed. Negative 60 divided by 3 is negative 20. X squared, take it away, that should go away. Then from here, I can factor this. I know it doesn't look normal. We have an x to the 6, but as long as these are half of each other, those powers, I can factor like I normally would. I can do my diamond method. Factors of negative 20 that add to a positive 1, well, that is 5 and negative 4. So this factor would be 3x squared. I'm going to use the middle value, the middle term, x cubed, because an x to the 6 is split evenly amongst 2 x cubes. And then my values are x plus 5 and x minus 4. If you could factor your groupings further, you would, but those are cubes and they're not perfect cubes, so I can't go any further than that. Okay, so that is part 2. Those are your short answer questions. You're going to have very similar ones on the final exam, just different values, and that is 30 total points. All right, part 3, your open-ended, are just a little bit longer. They're broken down into ABCs or multiple portions. Okay, so we have a model rocket launched from the top of a building. The height in meters is this formula, so that's going to be important for us to know. Where t is the time since the rocket has launched. So part A says, what is the height of the building? Height of the building is your starting. It says it's launched from the top of the building. So this is the starting point we're looking for. Your starting point is your y-intercept. Okay, your y-intercept is found by putting zeros into everything in your equation. So when when t is 0, h of 0 is going to end up just being your constant at the end. Okay, so the height of the building is 14 meters high. Okay, part B, a little bit of work. It says, what is the maximum height of the rocket? Okay, so you can put this in Desmos. You can use Desmos to help you, but then you have to screenshot all of that to show me, because you are required to show work here. Or you can use the formula x equals negative b over 2a to find your x value of your vertex. So if I use that, my a is negative 6, b is 24, c is 14 if I ever need that. I'm going to change this to t's just because that's the variable we have here. So negative 24 over 2 times a negative 6. T comes out to negative 24 over negative 12, which is 2. Once you have that, you're going to plug it back into the equation, and you're going to find what your height is. So h of 2, and this is just a matter of putting it in your calculator. You would put a 2 in for every t value, and you would find that the height at 2 is 38. So the maximum height is 38 meters. And remember, the t was your time, so that's why I'm not using 2 as the answer to this question. Okay, and lastly it says, describe where the rocket is ascending or the rocket is descending. So visually, my graph looks like this. I know it's a maximum. Okay, and I know where my maximum point is. It's at the point 238. So again, it's up to you how you want to describe it, but it ascends. The rocket ascends for the first 2 seconds up to 38 meters, and then descends after that. Okay, so you're just saying it's going up for the first 2 seconds until it hits that maximum height, and then it descends after that point. All right, so that's your first question. 10 points right there. Second question. So second question is all about adding, subtracting, and multiplying polynomials. Now you can physically go through and multiply all this. However, there is a much easier way of doing that for your degrees. So remember, the degree is the highest exponent. So in both these cases, I know that this one's a degree 7, and I know this one's a degree of 5. If I was to add them, I know when I'm adding polynomials, I'm just combining my like terms. So the exponents all stay the same. So if I was to add the g function plus the h function, that 4x to the 7th is always going to be my leading term because that's the biggest term amongst all of them. And I can't combine it with anything else. So the degree of my addition is 7. Same thing goes with subtracting. When I subtract those two, again, I combine my like terms just with subtraction. That 4 to 7 is still my biggest one. I don't care about the coefficient of it, what happens to that. I know the degree is still saying 7. Now, part C says, what happens when you multiply? Well, when we multiply those, we would have to distribute. Now, I'm not going to do the whole multiplication. In fact, I'm not going to fit all of this here. But if that would continue on, when I go to multiply this, I know I'm multiplying these two together first. So those two leading terms. Well, a 4x to the 7th times a 3x to the 5th is a 12x to the 12th. You would add those exponents when you multiply them. So the degree of the multiplication is 12. So again, it's just a matter of knowing that when you add or subtract, you're combining like terms, the degrees stay the same. And you take the higher of the two. And then when you multiply, you add your exponents. That then goes to part D. It says, in general, if all you know is that the g function has a degree of m and the h function has a degree of n, and I know that m is bigger than n, so I know that g is the bigger one. What are the degrees of the addition, the subtraction, and the multiplication? Okay, so in general, just like I said above, with the adding and subtracting, so g plus h and g minus h takes the higher degree, which is m in this case. And then in general, multiplication, g times h, adds together the degrees, which would be m plus n. Okay, so again, you just need to know that adding and subtracting, whatever your biggest exponent is in both polynomials, that's the one that you're going to use. And when you multiply, you add them. Okay, so this is a really quick and easy one. There's not a lot of work to do, but you do have to make sure you can explain it. All right, part 3, some probability. So you have 52 cards. I'm giving you the picture of the cards to even help you out. So part A says, find the probability of drawing a red jack. Okay, so first of all, these are my only 2 red jacks I have. So there's only 2 of them out of 52. You can choose to leave it as that fraction. You can reduce the fraction if you want. You can give me a decimal or a percent. I don't care. I will have all options available. But this is your basic. There's 2 red jacks out of all 52 of them. Okay, part 2, or part B. Find the probability that you draw a card, you get a face card, you do not replace it, and then you draw a second card that is a 4. So we're going to start with our face cards. So we know jacks, queens, and kings are our faces. There are 12 of those altogether. There's 12 out of 52. Then I want to get a 4. Well, here's all my 4s. But I didn't replace it. So of the 4s, there are 4 of those. There's all 4. And it's out of 51 this time because I didn't replace the card. Okay, So again, at that point, you can multiply it out. You would get 48. 4 times 12 is 48. 52 times 51 is 2652 if you want the fraction. Or you can give me the percent or the decimal. Now part C is the same thing, but now we're replacing the card. So the only difference between part B and C is the fact that when you get to the fours, instead of being 4 out of 51, it's 4 out of 52 because I put the card back in the deck. Whatever I picked the first time, I put it back in the deck. So I still have 52 the second time I pull it out. And again, from here, I would have 48 for the 12 times 4. And on the bottom is 2704. Or just give me the decimal. Again, you guys can put those in your calculators. And it says in parts B and C, which is your dependent and which is your independent. So remember, dependent is when things change. So the time that it changed was part B. Part B is dependent because you kept the card and the totals changed. Right? You went from 52 cards to 51, which would mean part C is independent because you replaced the card and kept the total in the deck the same. Okay. So we got another one that's not too bad. And then our last question. This was on your SGO test, if anyone remembers it. But we have a volume. So now we need to remember a volume formula. So volume equals length times width times height. Okay, that's the only volume formula you're going to need to know here. Length times width times height. That's what all these are. They're all the same even. So we want to come up with a polynomial equation that you can use to find the value of x. So the volume is 27. So when I set this up, I'm going to have 27 equals all of those multiplied together. So it's x times 1, or x plus 1 times itself 3 times, or x plus 1 cubed if you really wanted to have that. Technically that is it, but you do need to multiply it out so you can do the math. So we have 0. Nope, I'm sorry, we don't have 0. We have 27 equals, when you multiply all this out, you would do 2 at a time. It is going to come out to, so I do x plus 1, and then I multiply the back 2, x squared plus 2x plus 1, and then I can multiply the x plus 1 in there. After everything's cleaned up, it comes out to this. And then move to get the one side to be 0. It always has to be 0 for when we're solving for x's and polynomials. Okay, so from here it says identify the possible rational solutions of the equation in part A. So the way you're going to do that is we're going to go to Desmos, and we're going to type in that equation that we had. So I'm going to type in the x cubed plus 3x squared plus 3x minus 26. Well, here it is. That's the only one we got. I can zoom out as much as I want here, but you can see it's never going to change. So the possible rational root is 2. So you're going to write down here from the graph. Oops. Let me fix that. There we go. So from the graph, we found x equals 2. Now there is a whole rational root theorem where we could do the first term divided and the last term, the factors divided, but that's all I really need from you. We got the graph, we know it's 2. Part C says use synthetic division to find the rational root. And it's really to prove that it's the rational root. So you have to use this step. It is using synthetic division. So you take the value you found, which was 2, and we're going to do synthetic division now. So synthetic division is taking the coefficients of your polynomial, so 1, 3, 3, and a negative 26, and going through our synthetic division. So you drop down the first term, you multiply, 2 times 1 is 2, add down, 3 plus 2 is 5, repeat the process, 2 times 5 is 10, add down, we get 13, 2 times 13 is 26, add down, it is 0. And that's what you wanted to find. Your remainder has to be 0. If it's not, then we did something wrong. So we were able to find that this does in fact work, that it actually factors it to x minus 2. You take the opposite, and then x squared plus 5x plus 13. And if I was to solve these, x minus 2 is where that x equals 2 comes from. And this one is unsolvable. You can find your discriminant if you want to. That's when you take b squared minus 4ac, and you would find that 5 squared minus 4 times 1 times 13 gets you a negative 27. And because the discriminant is negative, this is not real, it's imaginary. So that's not a solution. Your only solution is x equals 2, which we saw from the graph. But I had to prove it because Part C asked for us to use synthetic division. And lastly, what are the dimensions of the cube? Well, each side was x plus 1. So that means if I was to put the 2 in, 2 plus 1 is 3. So it is 3 centimeters across all sides. So you could write it as a 3 by 3 by 3 centimeters. You could write it as length equals 3, side equals width is 3, height is 3. But this is the easiest route to go for your dimensions. Okay, and that is it for your final exam review. Hope it helps.